Well, good morning, everybody. So, Bruce, you're going to have to, I might end up really messing you up back there, Bruce. I'm like Pastor, I tend to walk around a lot. So these 3 days, I'm going to be talking about the universe and how it is obviously a designed piece of work by God, and I'm going to get into that next week. Today, I'm going to be talking about young Earth versus old Earth creationism. And I'll get to that in just a little bit. Now, I suspect all of you are young Earthers, right? And you know what I mean by young Earthers? Two important things. The universe was created in 6 literal 24-hour days, right? And that it is less than 10,000 years old. That's it. And I'll get to unpacking that bit in just a little bit. I remember when Pastor Fritz first came here, I was an old earther. I was a hardcore old earther. When I was a teacher in Janesville, I taught earth science. So I was kind of like really familiar with a lot of the material out there that talked about the age of the universe. And I was a hardcore old earther. And I'm going to get into what converted me into a young earther. And you can be a young earther and believe that the universe is quite young and still look at the world from a geologic point of view and examine the world and the rocks and the planets in our solar system and still be a young earther. We'll get to that. Okay, so what do I have next? So I'm going to read from Genesis 1. And let's note that this is on the 4th day, and it goes like this. And God said, "Let there be the lights in the expanse of the heavens to separate the day from the night." Okay, what separates the day from the night? The sun, right? When we have the sun, we have day. Other side of the earth, then China has day, but sun. "And let them be for signs and for seasons and for days and years." Okay, here's the thing. Should Christians cotton to astrology? Not astronomy, but astrology. And the answer is no. And by astrology, I mean signs like I'm a Cancer, I was born in July, Sagittarius, and Gemini, the twins, and so on like that. If you're into astrology, not astronomy, astrology, then you are saying the movement of the heavenly bodies has something to do with me. That is totally false. The movement of the heavenly bodies has something to do with itself, has nothing to do with me. Being into astronomy is the study of stars and planets. Being into astrology is fundamentally the study of yourself in relation to the movement of the heavenly bodies. Okay, but here it says God made stars, and let them be for signs. So how do we comprehend that? The stars are signs. Think back to, this has always fascinated me. When Jesus was born in Bethlehem, who went out to seek him out? The wise men, the Magi from the east, from probably Babylon, which is now Iraq. Okay, how did they know to leave their location and go to Israel? How did they know that? Stars. So the stars can be signs. The stars can indeed be signs. Not about my life and not about your life. If the stars are signs at all, what are they the signs of or for? The one who made the stars, Jesus Christ. Okay? So I always thought, wow, how interesting that God used the stars for some fellows out in the east, in Iraq, to get them onto their camels or whatever, to come over to Bethlehem. And who we have? Lindsay, Megan, and Connor. I don't think, have I told you my Bethlehem? I know I'm not told you. Connor, did I do my Bethlehem star lesson with you? Okay. One of my favorite lessons. Because what did the star do in Bethlehem? It stopped, didn't it? Okay, I've got a great lesson to give a plausible explanation of what that meant. Okay? Pastor Fritz will say he's siding on the side, it was a miraculous thing. I don't think it was. I think it was a natural thing. And that's my tease for you, for a lesson you'll never get. But if you go to bethlehemstar.net, you'll get the lesson. It's there. It's a guy. He does a DVD. Okay, so stars can be signs. So God made the stars. And kind of sub-purpose for a reason for people. But God does not make stars for you and me so we know who we should marry and whether we should go out and find a job. That's not it. That's astrology. Okay, keep going. And it was so. And God made two great lights, the greater light to rule the day and the lesser light to rule the night, and then the stars. So he made the sun, the moon. Oh, and he made some stars too. It's like, make some stars. And we're going to find out the universe is a breathtaking place. And God set them in the expanse of the heavens and to give light on the earth, rule over the day and over the night, and to separate the light from the darkness. God saw that it was good. There was evening and there was morning, and that was the fourth day. Okay, so the sun was created before plants were created, right? Isn't that interesting? So what nourished the plants? Well, God himself. In Revelation, it's God. There's a light that emanates from God himself. But God located that on the fourth day in the form of the sun. So let's look at some of the things that God made on the first week, okay? On the fourth day. Here's what God made on the fourth day. Boom, just like that. Whoop. Andromeda. This, by the way, this is one galaxy we can see with binoculars. Ben and I have done that. There's a Sombrero galaxy. Isn't that cool? These things are so beautiful. This is just a photo, with the Hubble Space Telescope. And then there are so many galaxies. There's Pinwheel, that very quickly, people who study these things, they just give them numbers. Forget about it. We're not going to think of names anymore. There's 6872, 2775. Isn't that one gorgeous? I love that one. There's 94. It looks like a Christmas ornament almost. There's 48, 45. And this isn't a galaxy, this is a nebula. Pismus, 24-1. Isn't that amazing? That's out there right now. And this is called the Mystic Mountain. So all this was made from God's command on day 4. Horsehead Nebula, there's the Horsehead right there. What else? And the Medusa Nebula. Awesome stuff. Okay, so, here's, there was a mission called the Cassini space probe, and its express purpose was to go to take pictures and study Saturn, and that's what it did. Eventually, I think it was in 97, it actually crashed right into Saturn. But this is the sun behind Saturn, taking a photograph from Cassini. Isn't that an awesome thing? The sun is just lighting everything up. That's so cool. Okay, and that's a real thing. That's not just an artist's mock-up. That's just a photograph. So cool. A lot of these, it strikes me that the universe is like a very clean place. It's so, there's no dust or anything. It's just crisp and clear and clean. Okay, so some more interesting facts. Sagittarius is not a galaxy. It's just a mass of alcohol. What it is, it's a galaxy-sized mass of pure alcohol. And it's a 10 billion liters of alcohol. So that's out there too. All that alcohol. Lindsay, never mind that. Here's another interesting thing, actually about our solar system. Anybody know what planet that is offhand? Connor? Neptune. Okay, and Neptune is the only planet that's actually, it doesn't rotate like Earth does. It doesn't rotate like any of the planets do. It rotates sideways, which is kind of interesting. And people can't figure that out because all the planets' rotations are synced with the sun's rotation, because the sun it mandates everything that happens in the galaxy or in the solar system. And the sun rotates east and west, so all the other planets rotate east and west. But Neptune does that. That's pretty cool. So in our own Milky Way galaxy, we have 400 billion stars. Okay, and remember, I just read in Genesis where it's mentioned, and God made the stars. So there are 400 billion stars just in the in the Milky Way galaxy. And how many galaxies are there? There are over 170 billion galaxies. And if you multiply that by just the Milky Way, in terms of stars, trillions and trillions of stars that exist in the universe, in a vast expanse of space. Okay, and I'm going to, now Bruce, get your hand on the volume just in case this is too loud. So how big is space? Let's go to that. How big is space? Whoop. Try it again. Back it up, back. And click. Oh, goodness gracious.
Between 1921 and 1929, Mount Wilson Observatory was the site of some of the most important discoveries in the history of astronomy. Here, more than a mile above Los Angeles, Edwin Hubble used this telescope to revolutionize scientific understanding of the structure, size, and origin of the universe. Working tirelessly from his wicker chair, Hubble determined that our Milky Way galaxy, thought by many astronomers to constitute the entire universe, was actually just one of countless billions of galaxies in a vast cosmic sea. Hubble also demonstrated that these galaxies were receding from each other, a fact that strongly implied the universe had a definite beginning. For a better perspective of the cosmos Edwin Hubble unveiled, let us embark on an imaginary journey from the top of Mount Wilson to the farthest reaches of the known universe. Traveling at the speed of light, 186,000 miles per second, how long would this journey take? Albert Einstein demonstrated that time would be dramatically altered for anyone traveling at such a speed. But for the sake of simplicity, we'll set aside this effect by measuring time with earthbound clocks. We depart Mount Wilson on January 1st. Hurtling through space, we quickly pass the orbit of Mars in just 4 minutes, 30 seconds. We continue on, past Jupiter and the other gas giant planets, Saturn, Uranus, and Neptune. And 5 hours and 30 minutes after leaving the Earth, we fly past Pluto and its companion moon. Our journey has taken us more than 3.5 billion miles to the outer limits of our solar system. And back at Mount Wilson, it's still January 1st. We now take our first steps into interstellar space. Behind us, our neighboring planets and the sun quickly disappear from view. The void of space is broken only by the glimmer of stars so distant they do not yet appear to move, even though we continue to travel at the speed of light. A year passes, then 2 years, 3, 4 years. Finally, on April 19th of the 5th year, we reach the Alpha Centauri system, the nearest stars to our sun. We have traveled nearly 25 trillion miles, yet our journey has barely begun. We are now 10 light years from the sun, far enough out in space that the stars within our galaxy appear to converge. 100 light years from the sun, patterns of gas and dust from an arm of the Milky Way galaxy surround us. 1,000 light years. The galaxy's arms and central disk become more defined. Yet it is not until we've traveled at the speed of light for 100,000 years that the entire spiral shape of the Milky Way is recognizable. From here on, each point of light we see is no longer an individual star, but an entire galaxy composed of billions of stars. 5 million years after beginning our journey, the Milky Way is recognized as part of a cluster of at least 30 galaxies, known as the Local Group. Bound together by gravity, the galaxies that comprise the Local Group span a region of space more than 3 million light years across. "50 million light years out, we encounter the large Virgo cluster, containing more than 2,000 galaxies. And so it goes, as we continue to travel deeper into the cosmos. We pass cluster after galactic cluster, each a building block of a far greater framework. 1 billion years pass. 5 billion. 10 billion. Finally, after 14 billion years, we are able to discern the large-scale structure of the entire universe. At least 100 billion galaxies stretch in thread-like chains across the cosmos, forming a tapestry of unimaginable dimensions. Today, scientists still ponder the source of a universe where uniformity and precisely balanced laws and constants enable us to survey its size and structure, to contemplate its origin, and to appreciate the profound reality of our existence within it, upon a remarkable blue planet, well suited for both life and discovery.
Okay, so did you catch how big the universe is from our point of view, the observable universe? 14 billion light years big. And a light year is how far 186,000 miles per second can go inside of a year. So 14 billion light years big. Okay, now God, on day one, God started fashioning the universe. That means the actual size of the universe. Stars weren't planted by God until day 4. But just, it's unimaginable that this could have happened, it could have happened in the span of a week, in 24 hours, 7 24-hour or 6 24-hour periods. It just blows my mind, something so huge. So, and it should, for me, it doesn't say much about the universe as it says about God. In just a moment, boom, he can do that. Boom, 14 billion light years. Boom, he can do that. And here's what's interesting to me is he just kind of mentions it as an afterthought. And I made the stars, when he was inspiring Moses. Well, yeah, he made the stars. He made Sombrero Galaxy, Andromeda Galaxy, all the cool nebula, just like that. Okay, that's how powerful God is. That just blows my mind when you think of, okay, let's examine what he did. Okay, he made the universe in a tiny fraction of a moment. All right, now, is the universe old or young? Old or young? It's 14 billion light years across. That's how big it is from what we can tell. It's probably even bigger than that. Old or young? Raise your hand if any of you ever considered seriously the question of whether the universe is old or young, or doesn't matter. Okay. I seriously considered it. And like I said, when Pastor Fritz was first here, he and I literally, guess what? I like to argue. And when he was doing one of his Bible studies, I argued with him for about 5 minutes. because I was, like I said, I was an old earther at that point. But being an old earther carries a lot of baggage, and I'm going to talk about that in a second. So, to be a young earther means this, means two main things. The universe is 6 to 8,000 years old, and everything in the universe is roughly the same age because it was all made in the same week, right? All right, that's to be a young earther. And to be an old earther means the earth is 4.55 billion years old. How did they get to that number? I'll show you in a second. And the universe itself is 13.8 billion years old. How did they get to that number? Okay, I'll tell you in a second. Here's how they got to how old the earth is. Backing up a second. How do we know that the young earth is a young earth? Two things need to fall, we need to accept as being true. Genesis 1 through 11 really happened. And because Genesis 1 through 11 really happened, that is to say the events, the people, and the places, and the times that are discussed in 1 through 11 are accurate. They really happened. Adam and Eve really happened. We're going to meet Adam. All of us. We are going to meet Adam. Okay? And we're going to meet Daniel and Joseph and all those guys. We're going to meet them, Mary. And then another thing to help us determine how old the universe is from a biblical point of view is called chronogenealogy. And I have a short little video that's going to explain that too. But it has to do with, in the Old Testament, there's this guy begat that guy, this guy begat that guy. And if you add them all together, then you get to a number. You get to roughly a little over 6,000 years. Okay, how about,
yes.
Back it up. Oh, okay, let's talk about chronogenealogy right now. Here's how we get to 6,000 to 8,000 years.
Yes, Genesis 5 and 11 contain genealogies with the chronology, the time between each of the individuals listed there. There are 2,008 years between the creation of Adam and the birth of Abraham. And since Abraham was born around 2,000, years, that gives you a creation date going back to Eden of around 4,000 BC.
The precision of that date obviously depends on when Abraham was born, and a few more years can be added because of the chronogenealogies are accurate to within 1 year of the event.
Yeah.
For example, we know that Adam was 130 years old when he fathered Seth, but we don't know if he was 130 and 3 months or just shy of 131.
Right, yeah, if all of the numbers recorded were just shy of their next birthday, was 130 and 11 months when he fathered Seth, and Seth was 105 and 11.
Goodness gracious.
Enosh, and so on. Almost another full year could be added to each generation.
We're going to skip that. All right, computer problems, folks. But basically, it's what you imagine that if you measure the all the years that are of the individuals in the Old Testament, how old they are, and then how old they were when they gave birth, or when their children were born, and so on. You get to that age, and we have to get to that age because our first parents, Adam and Eve, our real parents. Number one, they were created on the first week, the same week that Andromeda was made, the same week that the suns and the planets were made. Adam and Eve were made same week. So if we can get to how long ago they were, we get to how old the earth is. Does that make sense? Okay. So old earth, here's how they figure that out. And there are two ways to do it. One way is through radiometric dating. That is to say, carbon-12/14, uranium lead, or potassium argon dating. Now, what is radiometric dating? Okay, so you take a rock, and let's say it's a rock that's made mostly of uranium, but uranium is an unstable element, a radioactive element. It wants to decay, that is to say, it wants to lose electrons, and when it decays, it turns into a stable element, lead. You follow me? I got a rock, mostly uranium, but it's also turning into lead. So there's also lead composed of it too. Uranium, lead. So you take the percentage of lead that's in this rock, and you can tell how old the rock is according to a formula. And all these formulas add up to millions and billions of years. So it takes a long time for uranium to change into lead. So here's what happened. there was a big meteorite crash in Arizona, and Canyon Diablo, Arizona. The meteorite crash. Here's what it looked like. There it is, Barrington Crater. It's still there. All right? And a meteorite was retrieved from the crater, and scientists, what did they do? They measured the lead-uranium ratio in that meteorite, since it's not from Earth. And they figured out, okay, since it landed on Earth must be, and they plugged in a formula, I don't know what the formula is, but they've plugged in a formula, and Earth must be 4.55 billion years old. I don't know how they did that. But this is the chief culprit right here, this meteorite. Oh, my computer, goodness gracious. So, now what is not discussed, but what I think is also interesting, there isn't, when you're determining the age of the Earth, people use radiometric dating all the time. But that takes, these are scientists that have a certain presupposition going into the dating of the Earth, saying, well, yeah, the Earth is not 6,000 years old. Come on. So they go into it with a predisposition that the Earth is extremely, extremely old, and they start measuring ages that way. But all these other ways, there's ways to measure the age of the Earth. For instance, did you know that the ocean is getting more and more salty? Did you know that? And if you can determine the rate of saltiness of the ocean, and that helps determine how old the ocean is. Tree rings. Here's something interesting. Did you know that the moon is receding from the Earth by 2 inches a year? Now, the NASA missions put this cool mirror on the moon, and there's actually a laser that's shot, and it hits the mirror and it bounces back. And the scientists determined, well, how long did it take to do that? And that's how far away the moon is. And they're finding out, well, the moon is going away from the Earth 2 inches a year, which, did anybody here know that? I think that's interesting. So, but if you wind back the clock, what are you starting to get? The moon is closer and closer to the Earth, right? It can only get so close to the Earth before there's a huge catastrophe, obviously. No one knows how the moon naturalistically evolved. Many people think, well, it was captured by the Earth. Many people think there was a collision of some big thing. But if there's a collision between like a huge asteroid and Earth, how is it when something collides, and our Earth is 70% water, how does the water remain after a big collision like that? The water would just be scattered into space. Anyway, that's another example that the moon, for the formation of the moon. But one thing we know for sure, apart from models, is that it's coming closer and closer to the Earth. And if the Earth is 4.55 billion years old, there's no way. I mean, the Earth and the moon would be together as one thing at that point, if you keep winding back the clock. So it can't be. It can only be thousands. The scenario of our Earth and our moon can only exist for thousands of years, given the fact that the moon is receding away from the Earth. Okay, what else? Oh, here's our big thing. Now, the universe, by the way, what time is it? 49? Okay, perfect, I think. Okay, I think I'm a little running behind a little bit. Okay, if the Earth is 6,000 years, if the universe is 6,000 years old, how come we can see that at night? How come we can see starlight? Because remember how big the universe is? 14 billion light years. How come we can see Andromeda and all the other galaxies and stars through our telescope? How come we can see that? Do you see what the problem is? How fast can light travel? 186,000 miles per second. Okay, even at that tremendous rate, you can't go 14 billion light years and arrive on Earth. Okay, inside of 6,000 years, you can't do it. That's a challenge for young Earthers like me. There's a solution, but it's a challenge because we should only be seeing the planets and the sun, and that's about it. The sky should be black, but it's not. It's filled with starlight How come a young earther like us can see starlight? Because they're so far away. Here's how we do it, okay? Now hopefully my computer will cooperate. And give it a shot. I might have to explain this on my own. Now mind you, everybody sit up straight. We're going to be using our noodles at this point. It takes a little bit of thinking.
If the cosmos is young, as the Bible claims, then how can we see so much of it? Today, when a photon of light is emitted from a star at the edge of the universe, it will not arrive at the Earth until billions of years later. The size of the universe is a mystery that plagues creation science, and in the eyes of many, discredits the Word of God. Is the Bible wrong about the age of the earth?
Cosmology has been a tough problem for young Earth creation science. To solve difficult problems, though, it helps to know that there's an answer. I've found by repeated testing that the Bible is scientifically reliable. So now I use that knowledge as a roadmap to guide me into new scientific territory. I also use present scientific knowledge, knowing its limitations. But I require any theory, any new theory I generate, to conform to what Scripture clearly says. My best scientific insights, including my creation cosmology, come from following that procedure. Now, for example, here in Psalm 147, He telleth the number of the stars, He calleth them all by their names. Now, that word telleth in the Hebrew means to count. So God counts the number of the stars. That implies that they're finite in number, and that's emphasized by Him saying He calleth them all by their names. In contrast, verse 5 says that God's understanding is infinite, or in Hebrew, uncountable. So God's understanding is uncountable, but the number of stars in our cosmos is countable, or not infinite. So I can use that as a clue to guide me in making a cosmology, and I do, and many other scriptures the same way.
During creation week, God formed the stars and galaxies on the fourth day, and their light arrived no later than the sixth day. How did light traverse so much space so quickly? Did God just miraculously, by divine fiat, move the light across those billions of light years of space? Or can science offer any insights into how a physical process that normally requires billions of years might have occurred in a matter of just hours or days? Light itself is not the answer because its speed is fixed by the medium of space. Light behaves much like other wave phenomena, such as sound in air, or even ripples on water. Today, most people believe that space is, to put it simply, nothing. But now, physicists are beginning to realize that relativistic effects are best explained if space is actually something rather than nothing. Einstein came to this conclusion and spoke about it in an address delivered in 1920 at the University of Leiden. The title of the address was Ether and the Theory of Relativity. Einstein summarized his position in a singularly succinct statement by saying, "According to the general theory of relativity, space without ether is unthinkable."
The term ether, as Einstein used it here, means space itself, and dictionaries today still use that term in that way. For example, here in Webster's dictionary, a medium that in the undulatory or wave theory of light permeates all space and transmits radio waves or light waves. Now, Einstein's first theory, the special theory of relativity in 1905, tried to do away with the idea of an ether. But he found later on that his general theory of relativity, which he introduced in 1916, required an ether. Many people today are still under the mistaken impression that Einstein's theory of relativity does away with an ether, but as a matter of fact, a sophisticated ether is necessary.
We're running out of time, so I'm going to fast
for it
forward
to
this.
work.
Since the speed of light is fixed by the medium of space, that leaves time as the only variable that can explain how distant light could have arrived at the Earth during creation week. Time is merely the universe in action, the rate at which physical processes transpire. Science has discovered that physical processes and...
Okay, looks like I have to explain it myself. All right, so, sorry about that, we ran out of time. Think about this. Now, space is made up, well, gravity exists. It's one of the fundamental constants of the universe is gravity. And think of gravity like a bowling ball on a trampoline, and the bowling ball sinks down, right? And the center of gravity is the center of the bowling ball. So everything that has mass in the universe has a certain amount of gravity. Does that make sense so far? Yeah, I've got like 60 seconds for me to explain this. Gravity has an effect on time. Did you know that? When the astronauts return from Earth return from the moon or from the space station back to Earth, believe it or not, they're a little bit older than they would have been otherwise if they just stayed on the planet. Did you know that? Yes, they aged a little bit faster because the time clock of them spun a little bit, tiny fraction, a little bit faster. And it has to do with this. The more gravity that is present, the slower time is turned. This is Einstein's theory of relativity. The more gravity there is, the slower time goes. I'm going to repeat that because that's important. The more gravity there is, the slower time goes. So the theory then, starlight and time, is this. When God first created the universe, by time day 4, God had the earth in the center of the universe. But the universe itself is made up of a lot of stuff, galaxies and so forth. And it created what was called a gravity well, okay? Earth was on the bottom of the gravity well. And apart and separated from Earth are all the rest of the universe, galaxies and nebula and stars and planets. They were removed from Earth, okay? Now, Earth time was spinning along at 24 hours a day. However, Earth was in its gravity well when God was fashioning the universe. Higher up in the well, time was different because it wasn't as affected by gravity. The higher up the well you go, faster time goes. Okay? So all the other galaxies and so forth, they were higher up than Earth in the well, the gravity well. So their time was spinning along at their own clock. But relative to Earth, it was really going fast. Starlight was really traveling. It was traveling at 186,000 miles per second, according to their time. But according to our time down here in the bottom of the gravity well, it was going billions of miles per second, trillions of miles per second. Now that's kind of like, I'm not sure if that you guys are grasping what that is, but time relativity is a real thing. It's a real thing. And so the video would have explained it much better than I'm doing right now, but the fact that you don't have to change the laws of the universe, you don't have to say, well, God just did it that way and I'm going to accept that, and there's nothing wrong with that. If there's a way to comprehend the mechanism of God's creation and stay within the, okay, I'm almost done, and stay within the rules of scientific method, then I like doing that. I like explaining things that way. And the fact that time was different in different parts of God's creation, that makes sense to me. The starlight wasn't traveling any faster, but the time difference is what was the big difference. Okay, next week we're going to be a lot less complicated. We're still going to be talking about the universe, but next week I'm going to be talking about how it's really, really apparent that the universe is not only orderly, but fine-tuned to such a high degree. It's astonishing that it exists without a designer. Okay, astonishing. We'll get to all that stuff next week. So that's it. Thanks, guys.